Hello everyone. It's very lucky to have the discussion about how the PaaS to accelerate the digital transformation. So during the presentation, if you have any question, please leave your message online. Okay, first let's look at the challenge in our industry. According to a survey from the research company to more than 1,000 managed business executives, they are facing increased pressure to release the application in a more quickly way. So we know the time to market is very critical for your competition in your market and with the OTT companies. And also, the end user experience is another important perspective. So how to provide the high quality digital experience in a timely fashion is another very critical requirements. But at the same time, we know the situation in the telecom industry because our long-term evolution, we have very complex ICT architectures. For IT application, we have hundreds of them, and it's built with a different technology from the different vendors, and some of are in-house development. So how to change this architecture, how to transform the IT architecture to better meet the business needs is current the main major task of telecom industry. And at the other hand, the organization, in the previous journey, we have a separate business team and also separate our development team and operation team. From development team view, they have very heavy pressure from the business department, how to quickly to satisfy the business needs. So they need to change. But from operation team, they have different KPI. They want to keep the stability of the network and IT. And also from operation view, it's a very heavy task, heavy job for them to upgrade, maintenance, and also they think the change will bring the risk. So there's some war of confusion between the development team and operation team. So this is what we understand the challenges in the telecom industry in network and IT. Okay, so how to change and how to deal with these challenges? So let's look at the IT evolution, the trends. Firstly, let's talk about the development model. This model needs to transform. So we can see in the past several years, first we have a waterfall, this kind of development model, and then we evolve to the agile model. For agile, they try to for the development team more quickly to respond to the business needs, but they haven't addressed the gap between the development team and operation team. So the DevOps transformation will address these challenges. So for the DevOps transformation, it's not only the technology, but also the most important is the organization and the culture. So from the DevOps, from organization view, the organization need to transform from the independent silo function team to full stack cross-function and flat organization. And second, for the culture change, for the DevOps culture is try to improve the collaboration between the development and operation team, as well as other IT stakeholders such as architecture and information security. And also for the development phase and operation phase, they need to have the process to support the continuous integration, continuous deployment, and continuous feedback and improvement. All of this need a very strong platform and tools to support it. So this is for our suggestion for the DevOps transformation. And for DevOps, definitely they can improve end-to-end efficiency. But if application architecture is still traditional architecture, then the target will cannot be achieved 100%. So let's look at the application architecture, the evolution path. Before we have the monolithic the architecture, the application, they have very decoupled, they have a coupled architecture, and it's not easy to change. And then we move to the layered architecture. We have the multiple layer, we have a front end, we have a back end, and we have the ESB to integrate the different system. So that's called SOA architecture. And now it's very popular is the microservice architecture. So this microservice architecture that needs the application decoupled, and the architecture is the application is consist of the multiple microservice. Each service is independent to release, to deployment, and expose the RESTful API to external system or external service. So this is for the architecture evolution. This is very important. And another is for application deployment. So how to get the agile and elastic infrastructure is another perspective. We can see the first infrastructure part. Before, all the application is running on the physical server. Then we will moving to the virtualization to improve the utilization. And now we have the container to have a more lightweight mode to running applications. So, and for the container, we can see they have Docker. This is very easy to build in one time, but running everywhere. So from this three perspective, we can achieve the real DevOps. So from the development model, definitely need to transform, and application architecture, and also the application infrastructure in the very agile and elastic way to support application deployment and scaling and scale out. So this is we understanding how to change and how to address the challenge in the previous slide. Okay, but we understand in the telecom operator, you have various applications. You have BSS, OSS, MS, and for the networks, you have the core, you have a PCF, so different kind of applications. That means the challenge to transform this application architecture is not the easy way. And we understand most of application in the telecom is from the vendors. They buy the codes from vendors. So the development phase is managed by the vendors. So this is the reality. And also we understand for some operators, they have an in-house team to develop some digital service, some innovation applications to support the quick business demands. So we understand that there are these applications different types. Okay, so for what kind of applications we can choose to implement the microservice decoupling and DevOps? Here we recommend some principles. The first is for some codes. There is plenty of APIs, the decoupling based APIs. So the surround system can call the APIs and do orchestration and to create some functions. For example, in the BSS domain, the CRM system, it's have a lot of API needed to expose to surround system. So for this part, we can consider how to use openness of CM and to do orchestration and create some surround functions and capabilities. And another is your in-house applications. We know in a telecom operator, you have a lot of innovation ideas. So these innovation ideas should be implemented by some application, and your in-house team can support it. So your in-house team owns the source code, and then you can have the very efficient way to development and operate it. So this kind of application can be selected. And the third type is the web portal, the mobile applications. So this kind of applications, they have very high concurrency and need to bring the better experience to end user. So it's needed to change very quickly. So for this kind of application, it's also very easier to implementing the decoupling and to use the Devops mode. So this is here list some principles for to embark the application decoupling and Devops. Okay, so based on our understanding of the challenge and the telecom industry current situation and the application characters, so here we summarized how to transform and what kind of the targets can be achieved. The first, for the infrastructure layer, we understand now in the network and IT, some applications still deploy on the physical server and virtual machine, and some innovation application such as digital channels, they can running on the container. So we cannot achieve all moving to container. So in this stage, we suggest need to have a hybrid infrastructure for different application for different applications. So by this, we can improve the resource utilization and also provide the elastic scaling for the some applications. So and also we can achieve the real-time resource provisioning and automatic operation. So this can be helped to reduce the capex and opex, and finally to achieve the TCO saving. What's more, the most important is how to share the common capability of IT. You know, you have a different application development team. They have some common requirements for the middleware, for the database. So how to share this kind of capability and can be reusability and can be reduced. This is very critical and can improve efficiency. And also for application lifecycle management, from the development, from the operation. So how to use the PaaS platform to realize automation and improve IT efficiency, and to achieve the Devops for your in-house application. So this will be should be used about the platform and the tools, this layer. So for this layer, we can, for automation, we can provide the Kubernetes-based container platform, and also provide the continuous integration, continuous deployment development pipeline to support the end-to-end automation. And also in running time, we can provide the microservice governance, and also provide the microservice framework for development to easy to develop the microservice. And for middleware, we can provide the cloud service catalog to release this kind of the IT capability, and this can be used by the different development team. So this is for the platform tools. So based on the infrastructure and then the platform and the tools, we can support the multiple scenarios. So we understand the most important scenario for required for the agility and for automation, and required for the microservice architecture are in these three domains. The first domain is for 5G. According to the 5G 3GPP standard, 5G the core is designed based on the microservice architecture. So the best way to deploy it, the microservice is a container. So that need the platform to provide the very efficient, cost-efficient way to address the different vertical market requirements to realize the network slicing provisioning. So that's for 5G. And also in 5G, there are some edge nodes, edge cloud data center. So how to provide the lightweight mode to enable 5G. So this is one scenario we understand the PaaS definitely need to enable. And the second scenario is about the digital BSS. You know, for the BSS is manage your customer, manage your revenue, and it's the business requirements, they need to be realized in the BSS. So how to evolve from the SOA architecture to the cloud native to enable the business agility and the digital experience is a second scenario. And the third one is for the digital service. So except traditional telecom service such as voice and data, now the telecom operates to develop the video, IoT, and games. So this kind of digital service should be cloud native from day one. So how to respond quickly and cost-efficient way to this new business is very important. So we understand for telecom operators, these three domains, they are definitely require the PaaS capability to achieve the TCO saving, IT efficiency, and then finally to achieve the business agility and the better user experience. So this is what we understand the transformation targets for the telecom operators. Okay, so in order to help the telecom operator to address the challenges and provide the foundation for the telecom operator to achieve the Devops transformation, Huawei has built the PaaS solution fusion stage. So here we will introduce to you the overall architecture. So this fusion stage will cover the four parts. The first one is for the application scheduling and resource management framework. That means this will provide automation and lifecycle management, such as application modeling, orchestration, and container and hybrid resource scheduling, and auto-scaling, and application monitoring, and provide self-healing and support the flexible scaling and scale-out. So this is for the application scaling and resource management framework. This is for the deployment and the operation stage, the automation. And the second part is about in the development phase. We can provide application development pipeline framework. So automatically the continuous integration and continuous deployment. So for this part, based on the automation for two phases, for the operation phase and for development phase, so we can support the telecom operative team to transform to the Devops. And the third part is about the microservice runtime and governance framework. You know, for application, you need to transform to the microservice architecture. How easily to achieve this? So Huawei Fusion Stage provides the microservice development framework and governance management to support it. Later we have a detailed introduction about each part. The last part is to provide the cloud service catalog. For this cloud service catalog, we already integrate Huawei developed middleware such as distributed cache, distributed message, distributed database middleware, and also the telecom operator, your internal team, you can public or release the service, cloud service in this cloud catalog. And also your partner also can release the cloud service in this catalog. And then so your internal develop team or partner, they can use this the service, cloud service in this catalog for the application development. So this will increase the reusability. So this is the overall architecture for Huawei PaaS fusion stage solutions. Okay, so Huawei fusion stage PaaS solutions is based on the open source. So we can see for Huawei fusion stage for the container solution, we're based on the Docker and Kubernetes. So and then we are the top contributors in these communities, and also our fusion stage solutions already get the certification from the Kubernetes. That means our solution is an open solution. It's very easy to integrate with the third parties. This is for the container solution part. And for the microservice framework, we have one open source project, ServiceComp. This Huawei already open to the Apache community in the 2017. And in this year, this ServiceComp have become the top level project in the Apache community. Okay, this is the URL, so you can visit it and to get the more details about this microservice framework. Okay, so let's first look at about our container solution, the technology stack for application resource management and scheduling. Okay, so first let's talk about how this platform to achieve the application orchestration and scheduling. The first, we provide the hybrid application orchestration. What that means, this orchestration can orchestrate the application running on the virtual machine and container as well. You know, in telecom operator, some application, the architecture, you know, some module can running on the container, and some modules such as database or some other very back-end modules, they still need to running on the virtual machine. Okay, so our platform supports this scenario. We can provide the hybrid orchestration and to resource scheduling. And at the same time, we can provide the template for the application orchestration and management. And for the container, for the Docker image, we provide the software repository to manage it. So we can provide the private repository and also the public repository. And then they can manage the security of the image. This is about the software repository. And also this container solution integrated with the network and storage, and also integrate the multiple vendors, the us. And we already have some enhancement on the container network, and allow the users to attach the storage device to the containers. So this is for the container and virtual machine application orchestration and resource scheduling. And another part is about during the application running on this platform, we provide the application management, such as the fault-triggered migration. The system will monitor the application, the node. So if you find some issues, then they can, based on the policy, configured policy, they can trigger the migrate to another pod. And also provide the dark launch. That means A/B test. In the environment, they can, for the application, they can have two versions, such as A version and B version. So based on some rules, the external access, they can send a request to the different version. So that means A/B test, and also provide the rolling upgrade. So this upgrade will have no interruption for the service. So this is for the application management during the running stage. And also we will provide the comprehensive application monitor and operation. The monitor, and if we have some issues, we will generate an alarm and log and trigger the event. And also we can configure auto-scaling rules to realize the elastic auto-scaling and scale out. So this is about container solution, the platform capabilities. Okay, let's have a deep dive about each capability. The first one is about the hybrid orchestration of a container and virtual machine applications. Let's look at this picture. We can see we provide the very graphical orchestration interface. So you just can drag and drop the element, each element, to the GUI. So you can orchestrate the relation of application. In the application, they have multiple modules, so they can define the relation of each modules. And for each modules, you can click and to configure the resource specification and how to access and all kinds of detailed information. So after you design this orchestration template for the application, then you can save the template, and the next time you can select this template and to modify if you have some change. Okay, and after orchestration, you can click the one automatic deployment in the seconds. So this can be achieved automatic deployment. And for the deployment, we can support the two more policy. One is the affinity, supports the closest deployment. For example, some modules, these two modules, they need to deploy closely, so they can reduce the bandwidth consumption. And also in some modules, they need to provide high reliability, so we need to have some anti-affinity deployment mode. So this will minimize the breakdown impacts and avoid the interference of the different modules. Okay, so we can configure this to support the very flexible deployment for the application. Here, just the example, one application for their web portal and the backend, the logic module, they deploy under the Docker. But for the MongoDB, they will deploy the virtual machine. So we support this hybrid deployment orchestration and deployment, automatic deployment for the applications. Okay, so after deployment, so the application status needed to monitor. So based on solution, we have the unified application monitor GUI. So you can is very efficient and easy to monitor the healthy status of the application. First, we can have an overview. You can monitor each nodes of the clusters of the container clusters for the usage and how many applications, how many nodes, and how about the service, what's the status. This is the overview. And after clicked for the node, you can see for each node, we can see the CPU usage and the physical memory usage, and also each node's status, if normal or abnormal. So this is for each node's monitoring. And also on the nodes, we have multiple applications. So for each application, we also can monitor their status. And for the microservice-based application, we have a multiple microservice. So for each microservice, we also can monitor their status. Okay. So based on this container platform solution, we can support the automatic application lifecycle management. We can see summarized like this. First is faster resource preparation. So it's very easy to prepare the virtual machine resource and container resource for the application, and with the hybrid orchestration capabilities, and then real-time provisioning. And then after orchestration, and then we can achieve the one-click deployment. And then, so for the distributed application, we can deployment automatically. So this is for the fast application rollout. And then after deployment, if there have some increased traffic, the traffic surge, so we can configure elastic scaling rules to scaling and scale out. So this scaling will be in seconds. We can based on the scaling rules can based on the CPU, the memory, and also we can based on the transaction numbers. If we reach some threshold, we can scale out, and also we can you can based on some time, you can configure during the peak time, you can scale out, and also we can configure some very complex rules, and you can define your scaling rules by yourself. Then finally, you have some monitor. We have the application monitor system. So after monitoring, you have some issues. So we have self-healing capabilities, and to realize the intelligent application performance monitor and analysis. So by these capabilities, we can achieve the high efficiency of the application deployment and operation. So we can achieve the Devops of this stage. So compare with the traditional mode, we can see traditional mode, if they have some upgrade and new deployment, they maybe need 2 weeks, the long cycle. But now, based on this new platform, the automatic capability, we can achieve in 1 hour to realize it. So this is about the container platforms to solutions. Okay, just now we talk about the in the deployment operation stage. So how about the development stage, and bridge the gap between the development and operation team. So Huawei Fusion Stage have provided the cloud pipeline engine. So this engine will integrate the container platform with the mainstream CI/CD tools such as the Jenkins and such as the GitLab. Then we can achieve end-to-end automation. So after the development, they can upload the image to our image repository, and also can trigger the deployment to our system. So in our solution, we can provide the step-by-step visit to guide how to configure the open source tools and how to integrate with our Fusion Stage solutions. Okay, so we have talked about the automation of the deployment, operation, and development, and the bridge between the development operation. So from the end-to-end process view, we already we can enable the telecom IT team to achieve the DevOps capabilities, DevOps to support their DevOps transformation. But just now we think not the transformation, not only the process, the automation tools, but as well the application architecture transform. So if the telecom operator have some application, they have a very easy, have a lot of requirements, and always need the frequent change, and the architecture is needed to have a lot of the lot of the lot of the a lot of the challenge about to change. So maybe this will need to transform to the microservice architecture in the telecom IT, such as your digital applications, your CRM, and some of the video platform or IoT platform. Yeah. So this kind of applications, if they developed by the microservice architecture, we can provide the microservice framework. This will let the development team very easy to realize this change. First, we provide the multiple language development framework, so it's very easy for the development team to use. So they can use our platform and to select the SDK, and then they will generate some very common microservice code. And then the development team, they just focus on the business code of the application. Then to generate the microservice and then to have the complete microservice code. And for your existing applications already based on the microservice architecture, you also can access to our platform, can running our platform, and our platform can also provide microservice management. So this can be why the service mesh. Later we will introduce how to achieve this. And also we compatible with other open source projects such as Spring and Double microservice. Okay, so this is for in the development stage, we can provide this multiple language framework. And during the running stage, runtime, the microservice management, we can provide after the microservice developed, deploy on the platform. So need to register this microservice and configuration, how to access this service, and governance. So, and also we need to monitor the service and do some safety control and to ensure the transaction consistency of the distribute systems. So for the governance, we can support the basic governance such as microservice discovery, configuration, routing, and multiple transactions consistency. And also for the advanced governance include for break, the traffic limiting, and also the dark launch. So this is about the governance management. And also we provide some tools for the automatic generation, some service schema, and some automatic code generation for microservice, and also provide the automation document generation. For each service, they need to provide the RESTful API, so we can generate this API specification document. And for the microservice testing, we have an automatic testing tool for this microservice, and also provide the local debugging tools. So this is the whole framework of Huawei microservice. Huawei microservice is based on our open source project, Service Comp. Just now we already show this. Okay, here is just to show some way how the developer can use our platform to create microservice framework code. Okay, select SDK and create and generate the framework code, and the developer just based on this framework and fill in the business application code. Here for each microservice, so the team, they can configure the governance rules for the service. So when the service is running on platform, the system will based on the rules to monitor it and to handle how to handle the traffic, the transactions. Okay. So for the microservice deployment, we have two scenarios. The first scenario is for a new application deployment. If this new application is totally new development, okay? So so the DevOps team, they can log in our function stage platform and one-click generation the service framework code, okay? And then the service code, based on this framework, they can develop the service code, business logic, business code, and then they will build and then upload, deploy on our function stage platform. So based on this, we can provide for a new application development, we provide one-click framework generation, and we can provide out-of-box microservice basic capabilities such as micro registration, discovery, communication, and governance. And only the simple configuration required. So it's very easy to start. And also we can provide some local development and commission tools. So such as debugging tools. Also provide some developed sample code for multiple scenarios. So here we can have the tool ecosystem for the code generation, testing, and for the document, for the pipeline, and also we can provide the SDK for the multiple language, Java language and Go language, and also multiple programming framework, and multi-communication protocol. Yes, for language and communication can be select freely, and also we have the mechanism and capability to ensure the multiple transaction consistency. Yeah, this is very important for the distribute system. Okay, and the second scenario is your legacy application access. If we already have some application is based on other framework, is already deployed, develop the microservice, so you can download service mesh. Yeah, in our platform we already have pre-integrated this, so you can download the service mesh and then deploy the application service mesh with application, the application together. So after this, then our cloud service engine, that is the name of our microservice framework, they can automatically connect to the CSE for the microservice governance. And this scenario, no change for the legacy application, the business code, the code. And we can support the following the development language, such as .NET, Node, JavaScript, for this kind of the development language. So for our microservice work, we can support these two type of scenarios. So until now, we already talk about how the platform automatically to support the development phase and operation phase, and also in the development phase for the microservice architecture design, we provide the microservice framework to let the DevOps team to easy to develop the microservice and running governance their microservice. So, but what's more, in our platform, we can provide the cloud service catalog. This cloud service lag is very important for common IT capability sharing in your IT team, different DevOps team, and also with your partners. Yeah? So you can for your internal IT or partners, they can release the cloud service in this catalog. We already in our system have released some the cloud service from our partner. Some are general service such as Oracle, such as the open database, middleware, and also for some domain service for definitely for some specific industry. So, so we in this cloud service catalog, we already have some out-of-box service, so you can use, and also it's very easy. It's very efficient for your internal common IT capability sharing. So after, for example, one IT team, they have the release such as the MyCircle cloud service in this platform. So another team, they just can order this cloud service from MyCircle, and the system will automatically create the instance for these users. So this is the cloud service on demand mode to enable the common capability sharing in the DevOps team. Okay, so we already we have introduced most capability of Huawei Fusion Stage solutions, and also we understand the transformation for the telecom operator for to the DevOps. The application architecture transformed to the microservice architecture. It's not cannot be achieved in one night. Yeah. So from Huawei view, we suggest a stepped evolution from the traditional IT to the cloud native IT. Firstly, definitely we need to select the one open and the evolve support platform. So they can cover the current situation to support the virtual machine by mental, but also can support future capabilities such as container and microservice. So for evolution, we suggest in the step 1, we select some applications, this kind of applications such as web applications, because they have a lot of the requirements and need to bring the better experience for the end users. So we can focus on the automation for this kind of applications, the deployment and operation, and provide the elastic scaling capability for this kind of application. So for the first, we can, based on this, we can select to achieve the partial DevOps and auto development and scaling and high resource efficiency, and also build the service center for the developers to increase the IT efficiency. So this is for the step 1 or step 2. And for the step 3, definitely if some applications such as CRM and digital application, your IoT platform, they really need the use the cloud native architecture, microservice, distributed architecture. Then we can start this change. These transformations, they need the application have a lot of change, and also the microservice design is also need a lot of consideration. How to split the monolithic architecture to the microservice architecture. They need the business team, the architecture team have a lot of the consideration. So for this session, we suggest after achieve the automation for the development and operation, and then we can select the typical application to achieve the microservice and distributed architecture. So we suggest the step evolution approach. Okay, so here we want to share one case in China Mobile. In China Mobile, they have a lot of the base for digital service, such as games, video, reading. So they try to have innovation in the digital service. One of their digital service is the Migu games platform. So this platform, they have a very huge scale business. Supports the 30,000 Android games and 2,000 content provider partners and 200 channel partners. and cover the 200 million mobile users, and also have a very big revenue contributions for their partner and for China Mobile as well. So for this kind of platform, they have very type characters. They have very frequent change of business requirement, and they need a very good digital experience for their end users. And also, this kind of platform, they have a very high peak time, for playing games after work or after school. They will play the games, so they have some peak time. So for this kind of platform, so how to transform and achieve the agile capability can respond to the business innovation in a cost-efficient way. This is very important. So that's why the China Mobile want to select this application, this kind of digital service to change. So how to change? So they decoupled their architecture and then they deployed some. They have the Redis for distribute cache. This running on the VMware, and they have the Elixir load balance clusters. This deploy on the container, and also for the but for database, they still in a physical server, and this PaaS capabilities to support the multiple applications for the marketing platform, and for the game hall, for the user center, and for the short message bus, and also for the SDK token servers. So this is a container-based platform, and to support the these Migu games. First, we can look at what they are achieved. First is the service performance, because this solution platform they deploy on the container. This container is based on the environmental service, so they have a very good performance. And then second is about the resource utilization. Before they are worried about the peak time. They need to prepare a lot of resource in advance. But now they deploy on the container. The container solution, they can have a second level scaling, elastic scaling, scale out. So they no need to reserve so many occupied resource. So this improves resource utilization. And for upgrade, they have a lot of change. Maybe every week they need to have a new version. So they support the rolling upgrade and automatic upgrade. So this will saving the manual efforts. And the last one is not the latest one. They integrate with their developer tools. So to achieve the end-to-end automation, so can realize the fast iteration. So after deployment, this re-architectured this platform and deploy on the new container platform. We can see the feedback from a customer. Here is from operation team. This automation. They can save a lot of manual efforts, and also what's important is the time to market. Before, if they upgrade the new version, they need 3 days, then to 1 day for end-to-end process. And then for a cost, for the benefits, we can see they have auto-scaling capabilities, so can deal with the traffic bursts first, and then also they can have a very good experience for end users. And the second one is for the resource, the occupied resource by half. Just now we seen before, they just reserve a lot of resource in advance they are worried about the in the traffic bursts, what will happen? But now we have elastic capability, so they can handle the peak time. So this have reduced the investments about the hardware, and also save the costs. And this is for the capex part. And for the opex part, we can see the one is for R&D and test costs. We provide automatic continuous building and testing the tools, so this helps them save the labor by the 290 man-day per month, and reduce the costs by the more than 2 million China yuan per year. And another is improve the operation efficiency. So we we integrate with the CI/CD tools to establish the continuous integration, continuous deployment process. So this can be greatly improve the efficiency and the time to market. So, for example, the ZSDK version upgrade is shortened from the 30 to 5 minutes. 5 minutes. So this is the benefits and the result we achieved in the Migu game, transformed to the container solutions, and to achieve the CI/CD, and to to realize the development and operation transformation. Okay, so that's all for today's presentation. If you have any questions, please leave your question online, and then we will return to you later. Thank you.